Hello student, welcome back to chemistry laboratory. In this practical we are going to take the third experiment number 3, phenol water system. So in phenol water system, the aim of our experiment is to determine critical solution temperature for phenol water system. Now first of all we have to see theory regarding this experiment. Students, we know when two liquids mix in each other, there are three possibilities. First possibility is the two liquids are going to completely mix in each other. It will form the homogeneous solution. The second possibility is the two solutions partially mix in each other. So when in this situation, what will happen? The two layers forms, one layer is completely saturated with the other component, and second layer where the second component is completely saturated with the first one. And the third possibility is the two layers are immiscible in each other. So these three possibilities are there when we are going to mix two liquids in each other. So now in this experiment we have to study the second case, that is partially miscible system. The example of this system is phenol water system. So when phenol and water mix in each other, what will happen? It will form the two layers, because this system is partially miscible system. So in two layers, one layer where phenol is saturated with water, and the other layer where water is saturated with phenol. Now see here. So this is the phenol water system. So if you see carefully, in this case two layers are formed. So one layer is the water layer. So this water is saturated with phenol, and second layer is the phenol layer where phenol is saturated with water. So this system is partially miscible system. Now for this system we have to find out the critical solution temperature. It means now we know these two layers are miscible in each other while we are going to increase the temperature. Okay, so this temperature dependent, whatever the mixing temperature is there, so it depends on what is the composition of two components. Okay, so when we are going to take the two layer, that means two different compositions of system is there. Okay, now after increasing temperature, what will happen? The two layers are going to completely mix in each other. So we have to find out this miscible temperature, right? Now when we are going to mix this one, okay, we have to note down the temperature. So we have to find out critical solution temperature, means it is the temperature above which all the proportion of whatever the component A and B, whatever the component of phenol and water, percentage of phenol and percentage of water is there, when these two compositions are completely miscible at that temperature. So that temperature we have to find out, and that temperature is known as critical solution temperature for phenol water system. So now just see the experiment part. Now first of all we have to see what chemicals it's required. Now this is the phenol water system, so it's required phenol. Okay, so phenol is mostly occurs in solid state at room temperature. Then we have to take water. So while using the phenol, we have to take care about using the phenol, because phenol is highly corrosive to skin. So that's why while using the phenol we have to take special care, and we are not going to pipette out the phenol. Okay, so for that purpose for measuring the phenol we are going to use the cylinder. Okay, so cylinder we are going to use for measurement of phenol. Now phenol we are not going to measure on a wet box because we have to use with special care. So that's why we are going to use phenol as a liquid. Okay. Now we know the weight of phenol, means we have to take the weight of phenol because we want to find out the percentage of phenol. So for that purpose we have to know the density of phenol. So we have to take 10 gram of phenol, then 5 gram of phenol, 2.5 gram of phenol for various percentage of phenol. So for this purpose we are going to use the density of phenol. We know the density of phenol is 1.053 gram per ml. That means 1 ml of phenol it weight 1.053 gram. So accordingly we are going to take 9.5 ml of phenol when we are going to use 10 gram of phenol. Okay, so these are the instructions regarding using the phenol. Now for the experimental setup, it's required the water bath, or you can use the sand bath also. So mostly we are going to use here water bath. It's required the hard glass tube, then rubber cork, stirrer that is attached to this cork, and 1/10 thermometer. Okay, 1/10 thermometer means whatever the temperature we are going to measure, that measured with 1/10 accuracy. That means for 1 degree we are going to take its 10 part. That means we are going to measure up to 0.1, 0.2, 0.3 like that one. So if we see the room temperature is there, so room temperature is not, you are going to say 26, 27. So its room temperature becomes 26.5, 26.6 like that one, because the thermometer is 1/10 thermometer. Okay, so as here shown, so we have to prepare the setup like this one. Okay, now the experimental part. So what we have to do, first take the hard glass tube, then you have to measure 10 gram. So 10 gram means 9.5 ml of phenol with the help of thermometer, with the help of cylinder. Take that one in hard glass tube, add 6 ml of water in it. Okay, so you will prepare like this system, then dip in water bath, make the setup like this one, and heat this system with burner. Okay, so while heating, what we have to do, we have to continuously stir the mixture. Okay, why we are going to stir the mixture? Because we want homogeneous temperature at all portion of the system. So we are going to heat it and stir it. So while stirring also, we are just going to focus on temperature, what temperature is, because we have to measure the temperature at which the both solutions are going, both liquids are going to mix in each other, and it will becomes the clear solution. Okay, now see here, the system becomes turbid. So system becomes turbid means the two solutions are partially mixing in each other. Okay, two liquids are partially mixed in each other. When the solution becomes clear, we have to measure that temperature. Okay, so at what temperature it is going to mix, we have to see that temperature. So now the solution is clear. Okay, when it will reach at particular temperature, the solution becomes clear and it will see like this one. Okay, so when solution becomes clear one, okay, so this is the solution of water and phenol. So solution becomes clear, that means mixing temperature, we have to note this temperature as a T1 and we have to write in observation table. Okay, then what we have to do, just remove this one, just take the just remove the water bath from here and again stir it, so that we will again get the turbid solution. Now as soon as the solution becomes turbid, we have to measure that temperature as T2, and we have to take the mean of that T1 and T2. So why we have to do like this one? Because we know the heating procedure is the very fast procedure. We can't get the actual temperature of mixing. Okay, so that's why we have to take that first T1. Then the cooling procedure, this procedure is the slow process. So that's why whatever the temperature we will get, that temperature when the solution becomes turbid, that is the T2, then we have to take mean of this T1 and T2. So accordingly we have to take this one for particular composition of phenol and water. Now after mix it, okay, after this reading is completed, we have to add again 2 ml of water on that, so that it contains 10 gram of phenol and 8 ml of water. Because already 6 ml of water is there, we have to take 2 ml of water with the help of burette on that. Now the system becomes 10 gram phenol, 8 ml water. So what we are going to do? We are going to do just decreasing the percentage of phenol in the system, because initially it was 10 gram of phenol. If we want to find out the percentage of phenol on that, so simple formula is there. That part will be explained by Professor Kale sir. Okay, so now here in next step we are just going to decrease the percentage of phenol, do the same procedure, note the mixing temperature, and whatever when the solution becomes turbid, note that temperature as a T2. Again take the mean of T1 and T2. Okay, so similarly take 10 ml of water, 12 ml of water. So we are going to decrease the percentage of phenol and we are going to increase the percentage of water. Then just throw this solution in a basin and take 5 gram of phenol, that means 4.8 ml of phenol on that 10 ml of water, so that we are going to again decreasing the percentage of phenol. Okay, so this we are going to do as a set second. Then similarly do this one for 10 ml of water and 15 ml of water, find out the percentage of phenol, percentage of water, then take 2.5 gram of phenol. Okay, similarly do the same experiment, so that you will get the mixing, so that we will get the mixing temperature. So what we did in this experiment, we are just varying the percentage of phenol and water, and we noted the mixing temperature. So from this experiment we have to find out the critical solution temperature of phenol water system. Okay, we know critical solution temperature means it is the temperature above which all proportion of phenol and water is going to mix in each other. Okay, so this is the experimental part of this experiment. Now the next part, that is observation table and calculation result, is going to explain by Professor Kale sir. Yes, okay.
Hello student, as explained by Dr. Indulkar sir, we have to prepare observation table for this phenol water system experiment. So in this observation table, the first column is amount of phenol, that is 10 gram of phenol means 9.5 ml of phenol, and corresponding water component is 6 ml of water that can be taken with the help of burette. When we heat this particular system, we have to go for two reading. First is the T1. T1 is the temperature we can obtain while heating when the solution becomes clear one, and T2 is the temperature is obtained while cooling. At that time the solution becomes turbid one. So you have to find out T1 and T2 value for the first system, that is 10 gram of phenol and 6 ml of water. So two temperatures can be determined and we have to go for mean reading. So before that, we have to calculate the percentage of phenol and percentage of water. Percentage of phenol can be calculated with the formula, that is percentage of phenol is equal to weight of phenol divided by total weight into 1000. So here in the first reading, see here, weight of the phenol is 10. Then total weight means weight of phenol and weight of water. So this is 10 plus 6 into 100 is 10 divided by 16 into 100. It comes to be 62.5. So this is percentage of phenol for the first reading. Subsequently, the percentage of water when calculated by similar way, it is 37.5. It can be represented in observation table. So while taking second reading, just we have to go for change in amount of water, that is 10 gram of phenol divided by 10 plus 8, that is 10 divided by 18 into 100. This percentage of phenol can be represented here and percentage of water can be represented in water column. So in this way, before starting your experiment, you have to determine the percentage of phenol and percentage of water for every system under observation. Then when you start actual experiment, so we have to obtain the T1 and T2 and find out the mean reading. See here, for the first observation, suppose reading is 40 while heating, 40 degrees Celsius while heating. It is 35 degrees Celsius when the cooling process is there. So when we have to go for 40 plus 35, the mean reading is here. So we have to get the mean reading as 37.5 here degrees Celsius. So this is your first reading for the system. 10 gram of phenol plus 6 ml of water, heating, clear when the system is clear, the temperature is 40. When the system is turbid, temperature is 35. The mean is this. In this way, we have to go for taking the reading for every system, 10 gram of phenol, 8 ml of water, when the temperature, when the system is clear, temperature when the system is turbid, and the mean value. So in this way, we have to determine two temperatures, T1 and T2 for every system and find out the mean value of the temperature. Here this is the experimental part, and here we have to go for determination of all values of temperature. After getting all values of temperature, we have to draw or plot the graph for getting the value of critical solution temperature. So nature of graph, so in the x-axis we have to take percentage of phenol, on y-axis we have to take a temperature. Percentage of phenol is this column and temperature is mean temperature. So this is our mean temperature in degrees Celsius. So percentage of phenol, likewise we have to plot the graph with mean temperature. The points are like this, and we have to plot the graph. This is the highest point, okay. This is point when the temperature is highest, it is called as a critical solution temperature. It is in degrees Celsius, and the corresponding percentage of phenol is called as a percentage of phenol at critical solution temperature. So this is the nature of graph. This is the weight of percentage of phenol, mean temperature, and the nature of graph. And afterwards we have to determine or represent our result at first is critical solution temperature. It is in terms of degrees Celsius. Number 2 is percentage of phenol or percentage phenol at CST, critical solution temperature. And third one is percentage of water at CST, that critical solution temperature here. So this is your result table. We have the 3 representation in your result table here. In this way we have to go for determination of critical solution temperature and the percentage of phenol and percentage of water at critical solution temperature. Okay, thank you very much.